we are looking at difference of two squares. Difference of two squares. Okay, so this is a way of factorizing a kind of algebra, okay, a special type of algebra or a special type of algebraic expressions. So before we go ahead to solve some examples, we first need to know what difference of two squares is. Okay, so this is a method of factorization that is applied when a squared value subtracts another squared value. Okay, so this is a method of factorization that is applied when a squared value subtracts another squared value. So let's look at some things we need to observe here. One, a squared value subtracts another squared value. So for us to apply difference of two squares, one, we must see squared values, and secondly, what we'll be working on is subtraction, not addition. So if you have a question on factorization and you see subtraction, you see addition, know that you cannot use difference of two squares. So once you see addition in a particular question, you cannot use difference of two squares. So a good hint that you might apply difference of squares or difference of two squares is the presence of subtraction in a particular question. So the first thing you look out for is, does this algebraic expression contain subtraction? If it does not, then forget about difference of two squares. Okay, so let's say you've seen that the question involves subtraction. The next thing you should look out for is, does the question contains a squared value subtracting another squared value? So if you have a question like this, you are told to factorize 4x squared plus 8. If you are told to factorize 4x squared plus 8, the presence of addition already tells you that you cannot use difference of two squares, right? But what if you have 4x squared minus 8? The presence of subtraction gives you an idea that it's possible you might be able to use difference of squares, right? But let's see if a squared value is subtracting a squared value. Over here we have 4x squared. So this is a squared value, but is 4 a squared value? Yes, 4 is a squared value because 4 can be written as 2 squared. So we have 2 squared x squared. 2 squared x squared can be written as 2x all squared. So this side is a squared value. We found out that this side is a squared value. But what about 8? Is 8 a squared value? 8 is not a squared value because the square root of 8 is not a whole number. For this other value to be a squared value, then its square root should be a whole number, right? So because this is not a squared value, you cannot use difference of squares. But how about if instead of having 8 here, we had 16? Is 16 a squared value? Yes, 16 is a squared value because the square root of 16 is a whole number. So 16 can be written as 4 squared. So if this were to be 16 instead of 8, then we could have had difference of two squares because we can see subtraction, we can see squared values on this side, we can also see squared value on this side. So for you to solve difference, for you to factorize an algebraic expression using difference of squares, then you must find out if there's a subtraction sign here, there's a squared value to the left, and there's a squared value to the right. Okay, so let's look at some examples. We're expected to factorize x squared minus 16. X squared minus 16. So here we can see subtraction. So we've gotten the first step. Here we can see a squared value. So the second step got in. What about here? Can we see a squared value? 16 is not a squared value, but 16 is the same thing as 4 squared. So we can rewrite 16 as, so now we have a squared value subtracting another squared value. So since we have this situation, we can now apply difference of squares. And this states that when you have a squared value subtracting a squared value, then you can simply factorize them by adding the basis in one parenthesis and subtracting the basis in another parenthesis. I'm going to write it down. A squared minus b squared, a squared value subtracting another squared value. If you want to factorize this is simply a plus b parenthesis a minus b. This is what this principle states. If you want to factorize this, you simply add the two bases in one parenthesis, subtract the second base from the first base in the other parenthesis. Now, how do we know that this principle is correct? We can do that by expanding this expression. Remember, I've taught about expansion of algebra. So if you expand this, if you get this, then you know that we are correct. Let's see. A multiplied by a gives us a squared. A multiplied by negative b gives us negative ab. We are done with a. Positive a multiplied by positive b gives us positive ab. Positive b multiplied by negative b gives us negative b squared. But if you look at this, minus ab plus ab will cancel each other out. So we are going to have a squared minus b squared, which is this. So it shows that when you are giving a squared value, subtracting a squared value, all you need to do is open two parentheses, add the basis in one parenthesis, subtract the second base from the first base in the other parenthesis. So this is what the principle states. So let's see how this applies here. Okay. A squared value is subtracting a squared value. So we can open two parentheses. So in the first parenthesis, you add the two bases, x plus 4. And in the second parenthesis, you subtract the second base from the first base, x minus 4. And that gives you the answer. So you have been able to factorize this algebraic expression to become this using difference of two squares. Okay, so now let's look at another example. Minus 300. Okay. In questions like this, you might be told to factorize completely. So if we bring 3 out and open a parenthesis, 12 divided by 3 is going to give us 4. X squared divided by 1 is going to give us x squared. Minus 300 divided by 3 is going to give us 100. So now we have a way out because these two values here can be converted to squared values. Okay, so we can now have 3 parentheses. 4 is the same thing as 2 squared. So we have 2 squared, x squared, minus 100 is the same thing as 10 squared. So we are now generating squared values. But in indices, if you have 2 squared and x squared, you can bring the two bases inside and bring the exponent outside. So this will give us 3 parentheses, 2x both squared. So since both of them have squares, we put them inside and bring their square outside because both of them have square. Okay, minus. The second step is achieved. We have a squared value here. The third step is achieved. So now we can apply difference of squares. Difference of squares here, we open two parentheses. So in the first parenthesis, this squared value is added to this base is added to this base. Remember the base here is 2x. So we have 2x plus 10. And then in the second parenthesis, we have 2x minus 10. Okay, so we have been able to factorize this algebraic expression. Okay, so let's step back a little. We observe that we don't have perfect squares here. This is not a perfect square. This is not a perfect square. So we looked out for a number that will divide both of them, that will make them perfect squares. And we observe that that number will be 3. There are other numbers that can divide both of them, but we picked out the number that can divide both of them to make them perfect squares. Okay. So we picked out 3 and we used 3 to divide both terms. Now we have 4x squared minus 100. Now we are getting the perfect squares. So and put their exponents, give them a common exponent. And then we go further to use difference of squares. Okay, let's look at another example. So this is the fourth example. We have one more after this one. 100, this is quite easy. 100 minus x squared. So we're using this because you don't always have x in front. So x can be behind, okay? So, but we still follow the same process. We ensure that a squared value is subtracting a squared value. So here we have a subtraction sign. So that's the first step. Here we have a number, but is this number a perfect square? Yes. 100 is a perfect square because 100 can be converted to 10 squared. So this can give us 10 squared minus x squared. So with this, we have the difference of squares. A squared value is subtracting a squared value. So we open two parentheses. In the first parenthesis, 10 is added to x. In the second parenthesis, 10 subtracts x. 9x to the fourth power minus 9y to the second power. So we have 9x to the fourth power subtracting 9y to the second power. So this looks a little bit complicated, but it's not. I'm going to split the board into 2. So let's look at 9x to the fourth power. 9 is a perfect square, so we can rewrite 9 as 3 squared, right? 9 can be written as 3 squared. So this gives us 3 squared. X to the fourth power. Remember, it's difference of 2 squares. So we don't need to have to the fourth power. We need to have to the second power. That's a square. But x to the fourth power is something as x squared squared. Because when in indices, when you have a parenthesis between values, you can multiply the exponents. Okay, so this is the same thing as x to the fourth power. X squared all squared is the same thing as x to the fourth power. So we can replace this with this. Minus, so what we have here is this. 3 squared y squared. So now we have squared values. So also in indices, when two values both have squares, you can put them together and bring the squared value outside. So this can be written as 3x squared all squared. Let's see if we are correct. Let's see if we can convert this to this. So this square belongs to every value in the parentheses. So 3 squared is 9. 2 squared all squared is x 2 times 2, right? Because the parenthesis in between them is multiplication. So 9x to the fourth power. So this is the same thing as this, okay? So we haven't done anything different. So minus 3 squared y, since both of them have parentheses, so we'll bring them inside, all squared. So now, do we have difference of 2 squares? Here we have a squared value subtracting another squared value. A squared value subtracting another squared value. So we can apply difference of 2 squares. So we open 2 parentheses. I will bring these 2 into one parenthesis, 3x squared minus 3y, one parenthesis. In the second parenthesis, 3x squared, plus minus 3y. So we have been able to factorize this to become this. we can expand them. We learned about expansion about an hour ago. We can expand this to see if we can get this. If we expand this and then we get this, that means our answer is correct. Okay, that's the way of knowing that you factorized correctly. So let's see. 3x squared multiplied by 3x squared. 3 multiplied by 3 gives you 9. X squared multiplied by x squared gives you x to the fourth power. Now we are multiplying 3x squared and negative 3y. Positive 3 multiplied by negative 3 gives you negative 9. X squared multiplied by y gives you x squared y. So we are done with this. Now we multiply with this. 3y multiplied by 3x squared. Positive multiplied by positive gives you positive. 3 multiplied by 3 gives you 9. Y multiplied by x squared gives you x squared y. Okay? And finally, plus 3y multiplied by minus 3y. Positive multiplied by negative gives you negative. 3 multiplied by 3 gives you 9. And y multiplied by y gives you y squared. Okay. So now let's see. Minus 9x squared y plus 9x squared y. This is going to cancel out each other because they are the same, but they have different signs. It's just like saying minus 1 plus 1 is going to give you 0. So minus 9x squared y plus 9x squared y is going to cancel out. Okay? So we are going to see that we have 9x to the fourth power minus 9y to the second power. So that proves that what we got here is actually the factorization of that value. Okay? So that's just a proof. So I'd like you guys to try 2 questions from today's class.